Welcome to the Crestron 101 tutorial series. In this series, we'll cover the basis of Ethernet networking and how it can be used to maximize control of your Crestron system. In this tutorial, we'll discuss network topology and show you how to set up a network with basic and advanced security settings and how it relates to the Crestron world. Then we'll discuss wireless setup so you're ready for anything. By now, I'm sure you're familiar with Ethernet to some degree. If you've ever surfed the internet, you've experienced Ethernet connectivity. However, it's possible you've never set up a network to get there. In most cases, you turn on a computer and it just works, whether the IT department set it up or you bought a simple WAP for your home and used the default settings. When utilizing Ethernet and Crestron control, you open up a wider range of options to break out of the box of local control and bring connectivity to a whole new level. You can even use Ethernet communication to have two or more processors talk to each other, as well as connecting touch panels and other peripheral devices via Ethernet instead of CrestNet. Here are a couple of terms you should be familiar with. A network is a collection of independent computers, printers, and peripheral devices that are connected by cables. A network incorporating eControl will also typically include connected Crestron control systems, network control modules, and touch panels that control AV, lighting, and other equipment. Information travels over the cables, allowing users on the network to communicate, exchange data, and control equipment. Each device that connects to the network is called a node. Networks can have tens of thousands and even millions of nodes. Local area networks, or LANs, are usually confined to a geographical area, such as a single building or a college campus. LANs can be small, linking as few as 2 or 3 computers, but often can link hundreds of computers used by thousands of people. Wide area networks, or LANs, such as the Internet, combine multiple LANs that are geographically separate. So let's begin with the 3 parameters that you need to configure any piece of hardware for the Ethernet communication. They are the IP address, the subnet mask, and the default router, also known as the gateway address. The IP address is a 32-bit binary number that is expressed in a .quad format, consisting of decimal values of its 4 octets or bytes. The decimal numbers separated by periods are the octets converted from binary to decimal notation. There are 2 ways of assigning IP addresses, dynamically and statically. DHCP stands for Dynamic Host Configuration Protocol. What this means is that the router will dynamically hand out addresses to a device currently connected, and then free up that address when it's unplugged. If there is no DHCP server, or it's just a small private network, you can make up your own address scheme. This is called a static address, or one that doesn't change. If you're adding devices to an existing network, you will need to get an unused address from the IT administrator. But if you are the IT administrator, you can make one up. Most people use the address scheme of 192.168.1. a number, for the simple fact that this is not resolvable over the Internet. Typically, DHCP is used for devices that are not always present, or they move from one location to another. Administrators can create a user-friendly host name like Steve's Pro 2 to access the device once the address is issued. Static addresses are recommended for devices that are always on or serve as web hosts. Internet addresses are allocated by the NIC, the organization that administers the Internet. These public IP addresses are divided into classes, the most common being A, B, and C. The class of a network depends on its size. You can identify the class of an IP address by looking at the first octet as follows. Class A addresses are for large networks with many devices. These networks have 0 to 127 as their first octet. Class A networks can have up to 16 million hosts. Class B addresses are for medium-sized networks. These networks have 128 through 191 as their first octet. Class B networks can have up to 65,534 hosts. Class C addresses are for small networks. These networks have 192 through 233 as their first octet. Class C networks can have up to 254 hosts. In explaining subnet mask, I will attempt to give you a broad overview of a quite complex category. For a more in-depth look at subnets, refer to our eControl reference guide. Applying a subnet mask to an IP address allows the Internet router to identify the network and node parts of the address. An octet containing 255 represents the network bytes, and a 0 represents a node byte. Performing a bitwise logic and operation between the IP address and the subnet mask results in the network address. For instance, in a Class C network, you will use the subnet mask 255.255.255.0. In the octext defined as 255, the IP address of the device on the network must match that of the router, as shown on this chart. The fourth octet, defined as 0, means that the address needs to be within the range of the router. A default gateway, commonly referred to as a router, is a node on the computer network that serves as an access point to another network. The default gateway address is usually an interface belonging to the LAN's border router. In other words, it is an entry point and an exit point in a network. Now that we know what an IP address is, how is it used? In this basic scenario, we have a router, which is our gateway to the outside world. It uses encryption to keep out hackers and viruses and other people who aren't authorized to get into your internal network. The router is connected to a switch, which acts like a patch panel or central switchboard for other devices on the network to talk to each other. Each computer on the network is able to interact with others on the network. Next, we move to the basic setup of Crestron equipment. Processors and touch panels act the same as computers in that they each get their own specific address and have the ability to interact with other devices on the network. And since we have a computer on the same switch, you can use Room View and Toolbox to interact with the processor. Going one step further, we can add a wireless access point, or WAP, to enable use of wireless touch panels and even computers with wireless adapters. In this case, the touch panel talks to the WAP, which in turn sends and receives data to and from the processor via the switch. One more bit you may need to know about is control ports. Most of the ports listed here are defaults in the land of the Internet. For instance, whenever you visit a web page, you can be fairly certain that you're using port 80 to see the HTTP information. And if you've ever telnetted into a server, you're using port 23. Each manufacturer that makes equipment with Ethernet ports has a specific port number assigned to them. Crestron has 41794 and 41795, as well as a couple of others reserved for our use. Should you need to access a processor on a secure network, you would need to open up either one or both of these ports to gain access through the router, firewall, or security settings. Typically, we use port 41795 for console or toolbox diagnostics. We can run simple debugger or load firmware and projects just as if we were sitting in front of the device. Port 41794 is used for CIP, or Crestron Internet Protocol, which enables two Crestron devices to see each other, such as two processors on different networks. It is also used for e-control or web pages served from a processor. And don't forget, if you are serving web pages from inside a secure network, you will also need to open up port 80 for the HTTP information. For the next step, you'll need one of the cables shown here. For talking to processors and devices with DB9 ports, you'll need a straight-through male-to-female serial cable with all 9 pins. Well, really just 2, 3, 5, 7, and 8 if you're making one for yourself. Other devices such as a CEN iDock will have a smaller 6-pin RJ12 jack. The figure on the left shows the pinouts if you wish to make one for yourself, or you can purchase one from Crestron. So now that we have an understanding of what a network is, how do we incorporate it into the system? The first thing we need to do is configure the processor to join the network we're using. So you'll need to connect up to it using a serial cable first to give it one. If you're using a DHCP server, simply check the box labeled Enable DHCP, and an address will automatically be assigned for you. Assign the device a host name to be easily recognizable on the network. Also, notice the port number defaults we discussed. Most of the time you'll leave them as the defaults, but if you need to change them to allow for multiple processors behind a firewall, this is where you would adjust them. One other option available in the configuration is the communication speed, which can be set to auto-negotiate in most circumstances, but some routers and switches don't like that. In that case, you can manually set the speed to match the router's settings. As you define Ethernet